Welcome to Algebra, Negative Exponents. In a previous lesson on the quotient rule, we examined this expression showing how subtracting exponents is the rule for dividing powers. The result of subtracting 1 minus 3 for the b power shown here was negative 2, which is possible. Powers can have negative exponents. However, the meaning of a negative exponent is different from that of a negative value. The goal in simplifying expressions containing negative exponents is to convert them to be positive. This lesson will explore this process. Here is the expression from the last slide resolved to a final answer. Can you see what changed? Take a moment and study the difference between these last two expressions. First, see how the numerator value of the fraction, 1, was combined with the a squared power, resulting in a squared as the numerator. The negative exponent of the b power, in this case, simply means it moves down to the denominator, which has 2 as a coefficient, resulting in 2b squared. As soon as the negative power goes down to the denominator, the negative exponent becomes positive. A negative exponent simply means the power needs to move down to the denominator, or, if it's in the denominator, up to the numerator. As soon as the change is made, the exponent becomes positive. Here is the simplest possible example of this situation. The x power has a negative exponent, and so to resolve this, we move it down to the denominator and change the negative exponent to positive. Since there was no other value in the expression, the implied coefficient value of 1 remains in the numerator. Another example shows a negative exponent in the denominator, which, when resolved, just moves up to the numerator. Here is a more complex example with a negative exponent in the denominator. See how this resolves? Here we have two powers, x to the fifth times y to the negative 2. Resolving this one simply moves the y power down to the denominator and changes the negative 2 exponent to positive. In this one, the coefficient value 2 stays in the numerator with the b variable, and the x power with the exponent negative 3 moves down to the denominator, where the exponent value changes to positive. Check this one out, and see if you can figure out how to resolve it. Since the coefficient 5 is raised to the negative 2 power, it moves down to the denominator, and we square it to make 25. The x power joins it as well, with its exponent negative 3 changing to positive 3. All that remains in the numerator is the y squared power. In this example, more than one rule applies. We apply the power rule first, multiplying each of the exponents of the two powers inside the parentheses by 2, resulting in x to the fourth, y to the sixth, x to the negative 5, y squared. Applying the product rule, adding the exponents for x and for y, results in x to the negative 1, y to the eighth. Finally, the negative exponent is resolved, moving the x power to the denominator. In this expression, with negative exponent powers in both numerator and denominator, the powers simply change places. The coefficients stay where they are. Here is a fairly involved expression with several steps required to simplify the negative exponents. First, the easy one. 20 over 10 simplifies to 2 over 1. We also apply the quotient rule with the a powers, subtracting the exponents negative 2 and negative 4, which results in negative 2 plus 4, a final exponent for the a power of 2. Now we resolve the b power, again applying the quotient rule by subtracting the exponents negative 3 minus 3, resulting in negative 6 as the exponent for the b power, moving it down to the denominator with the positive exponent of 6. Finally, we subtract the exponents for the c power, resulting in 4 minus negative 2, or 4 plus 2, to make 6 as the final exponent for the c power. We have now accomplished all the necessary steps to simplify this expression by resolving all the negative exponents. Let's do one more. Here is a power of a power, which requires applying the power rule, distributing the exponent 3 to each of the terms inside the parentheses. First, 2 cubed is 8, and then x cubed cubed is x to the 9th. And finally, y to the negative 2 power cubed is y to the negative 6, all multiplied by 2 times x to the negative 4. Now we resolve the x powers using the product rule, adding the exponents 9 and negative 4 to make 5, and also multiplying the coefficients 8 and 2 to equal 16. Finally, we resolve the y power negative exponent by moving it down to the denominator, resulting in the final expression you see, 16x to the 5th over y to the 6th.